Well, thanks for attending this session on the benefits of virtual application segmentation. As she said, I'm Greg Tennant, Senior Vice President of Sales and Marketing and Strategy for Cybera. We focus on, basically virtualized network services. So we won't have any real pitches in here about us, but we're going to delve into a lot of the specifics around segmentation and how it's working and not working in enterprise networks today. I guess to start out with, I just have a few questions. Who here is out of town? From out of town? Is this all local crowd? We got a few in the back. All right, welcome to Nashville. How many people here would consider themselves non-technical? All right, that's good. So I won't kill too many people here, hopefully. Well, anyway, what we're going to try to go through today is a variety of parts of segmentation. So what is network segmentation? And specifically, what does it mean? And then what happens without proper network segmentation? And then why are network segmentation efforts failing in enterprise networks today? And I believe that there's ample evidence to prove that it is failing. And then what is the underlying causes for that? And that's not a simple answer, and it'll be covered throughout the presentation. But then what are you supposed to do about it? What are some of the alternatives that you really need to look at in order to address some of the challenges involved with the segmentation? Then we're going to get into a couple aspects of the dynamics of segmentation. So, vertical versus lateral breach propagation and how that relates to segmentation. LAN versus network-wide segmentation, and physical versus virtual segmentation. And then application or micro-level segmentation, and what would be some of the drivers of why you would want to go to segment at a more micro level in your network. And then, really get into the base concept of what is security really about? Is it layers versus segments? And then finally, try to leave you with an idea of what are some of your options out there? What can you look at, and what's a good way to look at a framework as to what options might be out there for you to look at as a resource or capability of segmenting your network. So what is network segmentation? By the way, this was from the original pay-per-view boxing match of Alfalfa versus Spanky. And I tell you, Alfalfa has one sick right hook. He's just, it's amazing. But no, really, the song we're playing, is kind of a thematic one for the subject of brought to us by The Offspring back in 1994. And although they were talking about how you keep gangs separated, it really does translate very well to the network environment, because we're all dealing with, multiple different, application traffic types, all, vying for a common resource, and that often creates lots of conflicts. And that conflict is really where segmentation, arose out of. How do we deal with better performance? How do we deal with those other things? It originally didn't really drive out of security, because at the time, the network was really a closed network. And so the security aspect wasn't really the primary driver when segmentation was really starting out. Now, if you look at Wikipedia defines this as the act or profession of splitting computer networks into subnetworks, each being a network segment or a network layer. I think when you look at the nature of a lot of the breaches that we're seeing in the industry today, that's probably not good enough. So I have my own kind of view on it, and that would be, better yet, the establishment of discrete networks that do not share common routing or security elements. And, that can be accomplished in a variety of different ways. And the reason why I say that is, as we go through the presentation, it's those common shared routing and security elements that are serving as the basis of lateral breach propagation and vertical breach propagation in the network. So I think something, needs a little bit more, and we need to really reshape the way we're thinking about segmentation to begin with. But no matter what your choice of definition, I think the general consensus is that segmentation, its advantages are to improve security, to reduce congestion, and to reduce problem cascade throughout the network, i.e. where one application begins misbehaving and then he begins affecting all the other applications, and then you're left trying to figure out where did it start and how do I resolve this. And that's a common problem that we deal with in today's connection-oriented networks. So what happens without proper segmentation? And I'm not going to pick on Target, because Target's been picked on a lot. But it really does serve as an excellent example for us to look at and to framework the way we're approaching security to begin with. The computer world came out and had this headline of Target breach happened because of a basic segmentation error. Well, that's true. You know, it wasn't how the breach started, but it is how the breach actually ended up in the payment network. All right, and there's part of the point here is segmentation shouldn't be allowing a breach that starts in one other area to end back up in the areas where we absolutely don't want them to be. So what's interesting about this is Target was is the second highest spending company on IT security, behind Best Buy but ahead of Walmart. So this really isn't a matter of how much money you throw at the problem. You can throw ample amount of money, most money that most companies can't afford to throw at it. And they probably had the best IT resources, very qualified, talented people. But still, errors are made, and there's a fundamental problem that wasn't there to solve, you know, to stop the propagation of the breach. So what really Target tells us is that, you know, it demonstrates that the connection-oriented networks by which enterprises base their networks on today are inherently insecure. Now that's kind of a challenging statement, and I can see a lot of people probably be like, whoa, 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 you got to back that one up. But we will, and so let's go through kind of what happened with the Target breach. You know, first of all, forensics showed that the Target breach happened through when a supplier of theirs, Fazios, which is an HVAC vendor, when their network was compromised. All right? Once their network was compromised, the intruders were able to compromise a computer inside of their network that contained the, you know, remote access credentials for a public IP VPN that they had, and then they were able to use that to get into the Target's invoicing and proposal application that they use for these vendors. Once they were able to do that inside of the store in Maryland, they were then able to exploit shared common routing and security elements and human vulnerabilities to laterally propagate from that finance application over into the payment application. And that's not supposed to happen. Target was PCI compliant. That shouldn't have happened, right? None of this should have happened. There's no reason why a breach should start in one area and result in the, you know, the loss of 40 million cards. So what else happened here? The intruders then, once they placed the skimming malware onto the PAWS system, and they placed it in an area that, you know, EMV wouldn't have really even stopped it. It would have not been encrypted at that point. And so they were able to skim off cards as they were going at the peak of the year, but then they were able to propagate this to the majority of other PAWS systems in the Target network in a very short period of time. So they vertically propagated across the MPLS backbone into other POS systems, which created a mass scale. So you compare what happened with Home Depot, they weren't quite on the mass scale, so they ended up with a huge number, I think it's like 50+ million cards that were taken, but it wasn't at the scale in the time frame, because Target breach only took about 3 weeks to 4 weeks before it was discovered. So the scope of the breach has a huge impact on the total damage that results. So the question is, if Target couldn't protect this network, why do you think you can? What are you doing that's so special that's going to stop that from happening? Can you throw more money at it than they can? I don't think many companies can do that. So, why are these segmentation efforts failing in enterprise networks today? It's a complex answer, but one of the key underlying drivers goes to the core architecture. And that architecture is the classic hub and spoke architecture. And this architecture has been around for over half a century. This is what we've been operating on in the majority of cases. There are mesh networks and other things, but in large part, it's a remote spoke connecting to a hub and where they aggregate all those connections back. Now, if you're a single site business, not as relevant, you have one site to worry about. If you have multiple sites, this becomes exponentially more difficult to manage as you go. But it is that hub and spoke architecture. It started out really defined to keep an enterprise network separate from the rest of the world. They didn't need to talk out to the rest of the world. It was defined to be private, and so internal traffic could flow as internal traffic needed to go. But when you have something like the pesky internet that decides to come around and start creating problems, and you have cloud services and Wi-Fi and mobility beginning to open up that network, it began to erode the hard outer shell of that enterprise network. And it created all of these different openings. And that different openings really creates a blurring of where does your network perimeter begin and end. Can you define where that is? Is it the employee who's downloading malware, by accident through being phished in email? Is it your vendor getting their, IPVPN hijacked and getting into you through the back door? Is it a SQL, script flaw in your website that leads to a back-end database? Is it a virus being introduced through a Wi-Fi network? Or on and on and on. There's so many different ways. The private enterprise network really no longer exists. And if we operate under the assumption that it does, we're operating under a false assumption. And that you can't really face reality under that premise. The reality is the attack surface area is broad and it's porous. And the reality is that breaches will happen. You can't stop all breaches. They will happen. CIOs must defend against all of these vulnerabilities, while hackers just have to exploit one. And if not properly segmented, a single breach can unravel the entire network. And now we've seen this again and again and again. And this goes to the heart of the matter, why segmentation is so fundamentally important. It takes only one vulnerability. So, let's go into the demise of this private hub and spoke network. This network won't continue to sustain. Actually, Eric Schmidt, the vice chairman of Google, at the Gartner Symposium in Orlando last year, laid it out very, very eloquently. He stated, look, it is just absolute folly that we think extending public IP-based VPNs into the heart of our network, opening up holes in our firewalls, is secure. It's not secure. He said, from his words, enterprises are going to have to rip out their existing architectures and they're going to have to implement application-centric network architectures. All right, so it's not me telling you that. That is, Google. And Google put their money where their mouth is. Google's one of the leaders of software-defined network implementations. They're not out there selling it as a service to enterprises. They do it for their own purposes internally. And they are probably one of the most advanced in the world at doing it. So, let's look at some of the data that says the enterprise network, as it stands today, is not a sustainable, secure architecture. First of all, 84% of companies, experienced five or fewer cyber attacks in the last 12 months. That's according to the Cyber Defense Report of 2014. All right, these are not uncommon. These are very, very common, and people are seeing them at maybe not necessarily greater frequency, but we are seeing greater success. 100%. Last year, in 2013, 100% of the breaches of POS systems did not start in the payment network. They started somewhere else, and they worked their way into the payment network. And 2/3 of all those breaches were caused by human error, i.e. mistakes. And that's according to the cost of data breach study of 2013. Even more startling is 99% of all breaches were discovered by a third party. They weren't discovered by the expensive malware detection systems that were put into the network. Actually, Target had a $1.6 million malware detection system, and it worked. They just couldn't respond to it. The complexity of the network, the tax on the IT resources, everything that they have to deal with is too much to respond. It took a third party to notify them that they had been breached. And the Pomenon Institute in 2012 did a study. And what they said was, under the current methods of security, enterprises will have to double their spending just to address 84% of the attacks. That's unrealistic. When it takes one vulnerability and you have to double your spending to just address 84% of the attacks, this is a losing game. Why do we want to still play it? So what do? You invert your security. My argument is you invert your security priorities and you do it now. All right, and the reason being, a network perimeter security breach is a probability. 65% of CEOs expect to suffer a breach, CIOs, I'm sorry, expect to suffer a breach in the next 3 years, according to the SafeNet survey in 2013. Rapid detection of a breach is an improbability. The average time hackers have spent in a network is 243 days. Target took about 3 to 4 weeks. Goodwill, 18 months. Michael's about 4 months. Home Depot, 6 months. These are companies with ample resources to try to address this problem, and they're not catching it. It's taking someone else to tell them that something's going on. That's a problem. There's something amiss in this whole situation. Part of it is that containment is an afterthought. We as security industry professionals are driving through the rearview mirror when it comes to containment. It's an afterthought. It is a reaction to a problem. It can't be a reaction to a problem. Containment has to be the basis of our network architecture. That's what Eric Schmidt from Google was saying. You can't go and try to fix it. If you try to go into an old house and try to make it secure, you're going to have to change out the doors, you're going to have to change out the windows, you're going to have to install security alarms, you're going to have to install video equipment. Overall, the cost of trying to accomplish that retrofit is going to be pretty darn expensive, and you're probably not going to catch every way that they could get in. If you start from scratch and you look at the architecture from how do I make this house secure to begin with, you're more likely to be able to do it, and you're probably going to spend less money in the long run. So effective containment is very difficult and very expensive to obtain in connection-oriented networks, i.e. the existing house. So let's go a little bit into lateral and vertical breach propagation. If you look here, there's a lot of ways that an advanced persistent threat can start. All right, we talked about a few of them here, but one way or another, it gets in, and it gets onto some system in that network. And from there, there's a couple different ways that they could get through. One, you could possibly have these different LAN segments, and you could have some PC over here that's connected to multiple segments. That's a big no-no, and that's happened, and that has been a result of some of the breach propagation that's happened. But a lot of the breach propagation happens because all of these LAN subsegments roll up to one access firewall. All right, and we're asking this one access firewall to cater to the needs of multiple applications with widely varying security policy requirements. All right, take payment. Payment has 220 PCI checklist requirements. All right, take Wi-Fi. It really doesn't have any. Yeah, sure you want content filtering. Yeah, sure you want to firewall it and segment it from the rest of the network, but there's no real driver for it. But the contrast between the security policy requirements of the applications that we're asking this firewall to accomplish is very difficult. And it's not even the firewall we're asking to accomplish it. It's the IT professionals that we're asking it to accomplish. Now, they could probably go in here and create an access control list that solves all those problems. And if it could say solid state and you froze everything in time, they could probably do a great job of securing the network. But then the real world's out there, and networks are dynamic. They're constantly changing. You're trying to roll out new applications. You're having to do new patches. You're having to add new access control rules to accommodate this, that, or the other thing. That cause and effect nature of changes in the network make the current approach so difficult to actually pull off that it's just not realistic to think that you can do it consistently every time. That's why 2/3 of the breaches are related to mistakes. So one way or another, that application, they're getting to the core firewall that's running this, and they're finding the vulnerabilities that are there to basically hop the VLAN or find the other route into the other networks. Because they're all using common shared routing and security resources. That creates the opportunity for lateral propagation. If that opportunity wasn't there, there's nothing to leverage to hop networks and get into the other networks and propagate that breach. So lateral movement is often enabled through vulnerabilities in the access router or the firewall. And this is a manual device-specific configuration. And that drives complexity and errors. The broader your network, the more devices you have to go in and change, the more ACL statements you have to go in and change. And you can try to cut and copy and paste them, and there's a lot of ways to do it, but it is a taxing, difficult, and typically an inconsistent way, because you can't expect a tech just to sit there and not be disturbed on anything or have his attention drawn away on something else, especially because there's lots of other things that are happening. Errors will happen, and they're more likely to happen in the current methodology that we design these solutions and make the changes to the network. Complexity equals vulnerability. And mistakes cause 2/3 of them, of the breaches. And the lack of effective internal security controls to stop exfiltration is one of the big problems. We're still operating in that hub and spoke architecture. That architecture wasn't really designed to create, significant and granular restrictions on internal traffic. It was designed for external traffic. So the lateral path becomes the exfiltration path in a lot of cases. So the security breaches rarely start in the payment or the patient data network, but they frequently end there. For breach propagation, MPLS VPN connections, they yield unobstructed access to the entire network. All right, MPLS doesn't provide any real security. It's a private IP network, but there's no inherent security to an MPLS network. There's this broad perception that it's secure, it's IP. I'm going to pay a premium for this. Other people can't pay the premium for it, so they use VPNs. And VPNs provide encryption and network level multi-factor authentication, but it doesn't provide user or application level multi-factor authentication. So it becomes, unprecedented access between the two endpoints that it's connecting. And malware on one POS system quickly spreads to all POS systems. So what is perceived to be the greatest strength, i.e. this big expensive private backbone, actually becomes the greatest weakness once you've been breached. So LAN segmentation versus network-wide segmentation. All right, today LAN segmentation, it's done through VLANs, wireless LANs, or collapsed LANs. And collapsed LANs being, a device or a router or a system that's directly connected to the access firewall and either statically IP address defined to it or pulling DHCP from that router. So it's not a broader, dynamically routed LAN. You can do logical or physical partitions. Logical partitions would be VLANs or SSIDs. The physical partitions are where you're actually putting in separate switches for each traffic type or even routers. And they extend from the LAN device to the WAN connection interface. And they almost always end there. There are other ways to do it, like adding L2TP tunnels, but that continues to drive more complexity because of the device-specific configuration that has to happen. The ACL becomes very, very complex. It becomes this very long policy statement, and the ability and the time to actually spend to go back and study that and say, oh, did I leave this remote desktop application port open or did I not? Did I take it out of every router that I was doing or did I not? It's not really realistic. There's 24 hours in a day, and most people don't have enough time to be that thorough and that detailed to truly pull this off. Traffic types are typically intermingled over this, all right? And this has broad and profound effects. If LAN segmentation basically stops here and there is no WAN segmentation, really what's the purpose of the segmentation to begin with? It doesn't accomplish that much at all. And when you think about the card data environment scope or the patient data environment scope and EPHI type applications for electronic healthcare records, that is defined by where data is captured, transmitted, and stored. All right? If you're transmitting this data along with all other data, that's part of your data scope. So now your task of getting compliance, you've just made far more broader than what it really needs to be. So you have to find ways to segment it. So network-wide segmentation, it basically takes the VLAN, the wireless LAN, the collapsed LAN, and it maps it directly to a software-defined network that extends for that application, that network traffic, all the way across the WAN to its endpoint. And from there, it creates virtual router and firewall instances for each and every application network. It removes that shared ACL, that shared firewall functionality, and it creates virtual instances for every one of these micro networks. And extends, and on the other end, it can hand off to another VLAN, or it can have an SDN handoff if it's a data center that's moved SDN at this point, to complete that end connection termination. It eliminates the complexity of the VLAN to L2TP tunneling, which becomes very, very complex. And it eliminates the device-specific manual configuration that you have to do in every device in your network. And the traffic types are never intermingled from end to end. Therefore, your card data environment and your patient data environment is collapsed down to this discrete 2 endpoints. And typically, that's a private IP connection. So LAN segmentation efforts are being defeated at the WAN connection interface. And it really renders them useless. We're spending a lot of time to do something that's only a half of a job. And that's not an effective way to approach it. So physical segmentation versus virtual segmentation. Physical segmentation is where you're actually, establishing dedicated circuits and dedicated devices for each and every application or traffic, subnetwork that you're creating. It's commonly LAN-based, and the WAN segmentation requires multiple separate circuits. Most business cases don't justify that. Some can for a while. As it's sustainable for the long while, it's typically not. Device specific for each connection. So now you have to add, discrete devices for every one, so you're exponentially increasing the complexity and the capital and the time and the labor that you have to do. And if you're dealing with a lot of distributed endpoints, then that really becomes an even more complex issue, because typically a lot of people with a lot of distributed endpoints don't have technical resources out at all those local endpoints. And end-to-end segmentation gets extremely difficult and expensive under the physical segmentation environment. And it breeds complexity, and it yields a very high tax on the IT staff. Virtual segmentation, on the other hand, basically is end-to-end based, and it leverages a common internet connectivity, all right? Typically, these are private IP networks. They can be public. Typically, they're statically defined routes as opposed to dynamically defined routes. And it uses a single network function virtualization router to enable all those logical connections, because it's creating different separate instances of those routers locally and then mapping it across to an SDN gateway of some sort in the cloud that could be either produced by you or that could be produced by a third-party service provider. And then ultimately to the end destination where it's going. The difference here is the application traffic flows go where the application's supposed to go. And we'll talk a little bit more about that as we go. It doesn't necessarily have to go back to the hub, be tromboned back down to the premise, wherever it is, the remote spoke, and then using very inefficiently a lot of the bandwidth that is very expensive. And this happens all the time. It doesn't require hairpinning out of the corporate location to get out to the cloud services. It basically allows the application to operate in a more natural and efficient environment where it's intending to go, but it's doing so in a secure manner. It eliminates traffic intermingling across the WAN, as we talked about, but it also provides centralized policy enforcement. The SDN model actually has a centralized universal policy controller, and so if you need to make a policy change to a particular network, you can make that policy change simultaneously across all virtual application networks that you define it for. And you can do it consistently, which is very key. So the economics of physical segmentation are difficult to justify. And as you roll out new applications, and those potentially impact the integrity of the existing applications you've spent so much time to secure, it becomes even more difficult to justify. It actually becomes a hindrance to the whole process of achieving your corporate strategic imperatives. We need this new application to make us more efficient. We need this new application, to make our customers' shopping experience better. We need this new application in order to, connect to more physicians' practices so that we can get more admissions into our hospital and, increase our distribution, so to speak. I mean, hospitals probably wouldn't say it from a distribution perspective, but the point is the same. So, how do you get to the point of how granular do I want to do this? When you look at microsegmentation or application level segmentation, it's also called microsegmentation commonly, and that is most efficiently and most feasible in SDN environments. That's the benefit of software-defined networks. And it places each app into its own dedicated logical network environment. It eliminates security policy conflicts. It reduces the CDE and PDE, patient data environment scope. It contains application and network server breaches to the affected network or application server breach or segment. It eliminates the propagation. It frees the application to take its optimal route path, and it reduces problem cascade, and it improves third-party access to the network, all right? Because you're able to then put specific application controls or security controls at user level, and then you can log that discrete connection, and we'll go a little bit more into those benefits here. But some of the drivers of why you want to get to micro is internet-facing apps, differing app security policies, unique app reliability requirements, an increasing ACL complexity, differing app route paths, improve your baseline monitoring quality. When you move applications into a more discrete environment, you can get a cleaner and more discrete baseline of logs, and you're able to detect anomalies more effectively. Third-party access, problem cascade, reduce attack surface reduction, and varying app latency threshold, but very specifically, app compliance is a great reason to get this down, so you can reduce that CDE scope. So security is about segments. It's not about layers. The security industry is feasting on the complexity of the enterprise networks. They're telling you, just buy more layers, you're gonna be more secure. But it's not proving out. Actually, it doesn't prove out to the 4,781 publicly reported breaches in the last decade. All right, that's over a breach a day, reported. How many go unreported? Probably, I don't know, I can't even estimate. But in a containment, segment-based architectures create containment architectures that mitigate security bleed. They create network perimeters that become more discrete and definable. They create syslog baselines that are concise, and they improve anomaly detection. And many of these, essentially what you're doing is you're stripping an application out of a dynamically routed environment and placing it into a point-to-point statically routed environment. Often that is private IP based, so it's not even visible over the public internet. Fewer layers are needed to defend it because you can define it. So security, the security about layers conventional wisdom has failed real-world validation. It's hard to make an argument to say, why would I spend another dollar on perimeter security when it's a probability it's not going to work? Why am I going to spend another dollar on detection when it's a probability somebody else is going to detect it before I do? Why would we continue to invest in the same losing architecture? Why are we going to play a losing game? We have to relook at this. We have to look at it from a basis of how is containment going to be the basis of my network architecture. So what options do you have? Some of the positioning variables, if you think about this, you can look at it from a perspective of what kind of solution types would I want to go for. All right, you could say I want to do, I've got a good, strong in-house security staff, and I want to be able to do this myself because I like that control. All right, so there's lots of options down here where you can go buy off-the-shelf hardware and software and do it yourself. You may look at it and say, well, I have too many remote endpoints that I can't, my staff can't adequately support this, and so I'm going to go in and I'm going to choose a managed service provider that does this. You could say, look, my business is X, it's not security. This company's business is security. That's who I need to partner with. It's those type of decisions that would drive what kind of solution type do you want to pursue. Then there's solution methods, and there's the connection-oriented methods that drive the physical segmentation model, and then there's the virtual segmentation methods that are beginning to evolve out there, and they give you that virtual segmentation model. All right. Now, the truth of the matter is these are a lot of very vested, very strong, most of them very well-established players. The message you're going to continue to hear is buy more layers. We've got more layers. We've got a more advanced firewall. We've got more advanced access control. We've got more. Great, but is it going to stop? Is it going to change my architecture? No, it's adding to the architectural problem. So I'm telling you, this isn't really where you want to be focusing your time, money, or efforts, or resources. The virtual segmentation model, you probably do. Here, you have a lot of new startup companies. They're being funded by venture capitalists, heavily coming out of California, some out of Texas, some out of Boston. Most of them are stealth mode companies, and they don't have a product yet. They've got a grand vision, and they're going to go out and deliver it. So over time, you're going to see these guys evolve, and they're going to be viable options. Nobody's, this isn't rocket science. Everybody can figure out ways to do this. In the cloud market, you've got a variety of different cloud service providers that do provide SDN-based services in virtualization. But a lot of these guys still rely on connection-oriented devices because there really aren't third-party devices that they can buy that are virtually oriented out there today. Now, the only plug I'm going to put in here today is really what Cybera has done. And we developed our own appliances that go on the remote site and appliances that go in the data center. And we provide it as a managed service, but we also have methods of enabling that in an extended mode to your data center. And we've been doing this for about 3 years. We have about 30,000 sites in production with some of the top blue chip companies in the world: Shell Oil, ExxonMobil, Little Caesars, O'Reilly Auto Parts. And so we've been doing this. We do have experience in this. And I think we are considered the leader. I mean, I can self-proclaim us to be the leader, but I think we're the leader. But I think we bring a lot of experience. But there are a lot of options. And given time, there's going to be more options. And so you do have options coming out there. There are options to change your architecture. You just have to figure out what's the right one for you. There are many many emerging options, but few proven options. All right, so leave with something a little humorous. Virtual segmentation is containment without physical barriers. I thought this was pretty funny, but you'll have to choose for yourself. But I'd really like to stop right now and ask, do you have questions? I'll try to give about 10 minutes for question and answer, see if you have any specific questions, and hopefully I didn't make your ears bleed on something at all if you thought you were non-technical. But is any questions from the audience I can answer at all? I know I'm competing with happy hour. So, yeah.
You talked about being able to do this for a hub and spoke model. Mm-hmm. Can that be extended for a data center where you want to, if you have different data classifications, different applications, can you really extend this kind of an architecture for a whole data center?
Absolutely. That's not something Cybera does, but absolutely. Actually, SDN has really evolved around the data center. And there are a lot of different options emerging out there. The biggest challenge around it today is not that the technology doesn't exist, is that there is no standard around it. So you're kind of taking a buyer's remorse potential approach to it. That you bet on a vendor that doesn't last or gets acquired and taken off the market or whatever. But SDN in the data center is the most evolved of all. And when you look at SDN in the extended model, that's where SDN and the data center and SDN versus enterprise are very different, because SDN in the data center relies on OpenFlow and this interface that allows you to get in and control third-party devices. And that's where the rub is in the standardization. Cisco has no vested interest in letting other people into their devices. So there's a lot of evolution that needs to happen. Will there always be this one beautiful, perfect standard? I think history tells us it won't. Cisco always tends to have their standards-ish solution. So there's always going to be complexities to it, but in the data center, there are more options than there are in the enterprise or the extended model. In the extended model, the OpenFlow model just doesn't work. There's no service provider out there who's, routing public internet traffic that's going to let you get into their network. It's just not going to happen. So you have to create virtual overlays to that. And that's where the managed service model in enterprise tends to add more value, because that service provider is providing that extended connectivity over its network, providing that SDN application virtual network functionality. But you can do it with devices and put a gateway in your data center and remote devices out there. The main difference is, your selection of security features, the high availability functionality that you get versus, a point-to-point device to data center connection versus what a service provider may be able to provide you in terms of a greater level of high availability. Does that answer? Okay. Any other questions at all? Yeah.
So it seems like in the hub and spoke, you've got this hub that's your weak spot. In this model, it sounds like you've got two hubs on either end.
I see what you're saying. I would say that in the hub and spoke model, the hub tends to be more highly fortified and a little more concentrated and probably the more secure end of it, and it's the remote sites that tend to be the more vulnerable. But do you have two hubs? No, what you have is two logical endpoints, all right, that define the network perimeter of that particular traffic route. And when you think about it, you're like, okay, wow, I run 10 applications, I got 200 sites, you're talking about 2,000 networks you're telling me to deploy? Are you crazy? I'm having a hard time doing what I'm doing. But remember, in the SDN model, though, you have the universal policy controller, and it actually becomes far more efficient, because now you can take those 200 sites with the one particular virtual application network you're looking at. I guess it's telling me I'm done. Where's the hook? You're really dealing with more very discretely defined network paths as opposed to hub and spoke. Because now, those paths can go anywhere. They could go to a third-party network, they could go to a cloud service, they could go to a corporate data center, they could go to another corporate office, so whatever they might be. It actually eliminates the hub as the concept, and it puts it into discrete defined network paths, and typically, like I said, they're private IP static routes. They don't have to be, but a lot of times they are. Did that answer the question? Okay. Any other questions? All right, well, thank you very much. I appreciate your time, and I hope you have a good day.